Hello, so today we're going to talk about how to solve linear equations. First, let's talk about what an equation actually is. So an equation is a mathematical expression that contains an algebraic expression and an equal sign. That's the important part. All your rules for math still apply to the equation itself when you're adding, subtracting, multiplying, dividing, but now it's a little different from an expression because of that equal sign. To solve this, whatever the variable is, you need to move that to one side of the equation, and everything else has to move to the other side. The key is isolating the variable. When you're moving the expressions around, you're going to use your rules of PEMDAS, working on one side of the equal sign. So don't forget that. Make sure your exponents, you apply the rules in the proper order: exponents, multiplication, division, parentheses, the whole thing. If you're moving an expression to the opposite side of the equal sign, you must add the opposite. So if you're moving from left to right or right to left, if you have like a +4, you would have to subtract 4 to move it. If you're doing it 2 times an x, you'd have to divide by 2 to move it. You always have to do the opposite sign or the opposite expression to move it around. So let's solve some of these basics. So we have x minus 4 equals 12. Well, this is a simple one. We're trying to isolate the variable x. So to do that, we need to move this 4 over. Since it's a -4, to move it, we have to add 4. We do the opposite. And then 12 plus 4 is 16. So our answer is 16. Simple as that. Again, whenever you have a minus sign like that, you're going to add to move it around. If we have a plus sign, opposite concept. Since we are having a +3, a positive, to move it around, we need to do subtraction. The key is, when we do this, so we have x just by itself. 3 minus 3 is 0, that's why it went away. And 8 minus 3 is 5. So our solution is 5. Now, if you're ever not 100% sure that your answer was correct, if you plug it back into the original expression, you should get the left side equal to the right side. Now, you don't need to do that every single time, unless your teacher requires you to. But it's one good way to check yourself in the beginning until you become more comfortable with the whole solving process. Now, if we have -2y equals 18, we're now dealing with the multiplication case. Well, opposite multiplying is dividing. So we have to divide by -2. So the -2's cancel there, leaving y equals, and 18 divided by -2 is -9. So y equals -9. And that's the other thing. You'll generally see x as your variable for most of these equations. It's just a common notation. But any letter that your teacher wants is allowed to be used. So keep that in mind. Just know that's the variable. You need to isolate that by moving things around. So we have 1/3 of a equals 4. Now there's 2 different ways to think about how to deal with fractions. You can always, with a fraction, multiply everything by the denominator, the bottom piece, to clear out the fraction, deal with just only linear equations. So if I multiply both sides by 3, 1/3 times 3 is 1, that's why it's just a. 4 times 3 is 12. And we're done. The other way to think about how to deal with fractions, if I rewrite it, 1/3 of a equals 4, if you multiply by the reciprocal, which in this case is just 3 over 1. Same concept, we get a equals 12. The reciprocal concept is a little more useful when our fraction right here is more like a 2/3 a, or like a 7/3, something where 1 is not the numerator. That's where the whole reciprocal concept comes in a little bit more into play. But again, if you just multiply everything by the denominator, that will clear out the fraction every single time. So those are your basics. They're considered what we call one-step equations. Now, intermediate equations are what we call multi-steps. There's at least 2 steps in all of these problems. Generally, they will combine the concept of adding, subtracting, and multiplying and dividing. Those are the 2 basics for these equations. Now, to solve equations, you will generally want to solve them in reverse PEMDAS order. Deal with all your adding, subtracting first, and then get rid of your multiplication, division, then deal with the exponents, and then deal with your parentheses kind of stuff. That's generally how you want to solve these problems. Now, you can divide immediately, but then if you divide everything by 2, off the bat we'll have fractions, it'll be nasty. So let's add 5 to both sides first. So 2x equals 16. Then we divide both sides by 2, and x equals 8. So there we go. It's the same exact process, but now we're combining 2 different equations into one. Let's take a look at another one. So we have -6b plus 7 equals 12. So first thing we want to do is we need to subtract that 7 from both sides. So we have -6b equals 5. and then we divide both sides by the -6. And now 5 and -6 are not divisible, and I can't reduce that fraction. So my answer is just a -5/6. We move the negative to the top part. It's just common notation to write the negative of a fraction either up top or in the middle rather than on the bottom. You also could write that as a decimal, but if you're writing as a decimal, you're required to round it. So that's not necessarily advisable, plus more work for you, unless, again, your teacher wants you to round that as a decimal, in which case follow whatever decimal rounding rules they have. Me personally, I'd rather leave it as a fraction. Okay? And that's the thing also with these problems. They're not always going to be whole number solutions. A lot of times they are fractions. Now something like this, we notice we have 4z minus 13 plus 3z equals 20. So what we have here is another type of multi-step equation, but now we need to combine like terms. In all the previous problems, our variable was alone. It was only a single variable. Now we have two of the same variable. So now we need to use our PEMDAS rules. We need to combine them. 4z plus 3z is 7z. So we have 7z minus 13 equals 20. Now we have an equation like we just dealt with. So we add 13 to both sides. So 7z equals 33. And then divide both sides by 7. And z would be, 7 does not go into 33. So I'll leave it as the improper fraction 33 over 7. A mixed number, which would have been 4 and 5/7, is perfectly acceptable. And then the decimal equivalent, again, is also acceptable. But again, I'd rather not write them as decimals. Okay? So we're still using the same process, but now we have to apply different rules to actually combine our like terms first. So again, the key is always, if there's more than one variable, they need to combine in some way. Whether they have to move, they're on the same side, add them or subtract them together, or if they're on opposite sides of the equation, move it around from left to right. Either way, all the variables must be on one side. Now this one, again, we're dealing with our fraction. 3/2 d minus 5 equals 4. Now, two different ways to look at this. You can clear up the fraction immediately by multiplying everything by 2. We would get 3d minus 10 equals 8. So we add 10 to both sides. 3d equals 18. Divide by 3. And d is 6. We also could, if I rewrite it, deal with our reciprocal concept. Now the thing with multiplying everything by the reciprocal is I want to wait until I have the variable completely isolated to do that. Because if I multiply everything by the reciprocal right now, I'm multiplying everything by 2/3. So I have to multiply 5 by 2/3 and 4 by 2/3. And 2/3 is not multiplied nicely with 5 or 4. So I want to try and avoid messy problems as long as possible. So we would add 5 to both sides first. Get 3/2 d equals 9. And now when I multiply by my reciprocal, 2/3, 9 times 2 is 18. 18 divided by 3 is 6, and we have the exact same answer. So it's your call. I generally like to get rid of the fraction for more complex looking problems like this one right here first, and then just have a linear equation, no fractions, and much easier to deal with. If you like multiplying by the reciprocal, this is perfectly fine. And I'll pause. Sorry about that. I'm recording these in school during one of my prep periods, and that was the bell, so sorry about that loud noise. Alright, so next problem. So I want you to solve these 4 problems on your own using what we just talked about, your simple rules for solving equations. So go ahead and pause your video to work out those solutions, and I'll provide the answer for you to check your work against. Alright, so you should have gone -6 for the first one, 20 over 3 for the second one. If you ordered rows decimal, it would be 6.6 repeating. 3w is 11/4, 2.75, and 4a would be 8. Alright, so now let's deal with some more advanced equations. A lot more going on for these problems. So for this one, we have 2m minus 13 equals negative 8m plus 27. So now, again, we need to combine our m's, but now they're on opposite sides. So our rules still apply, though. If I need to move this negative 8m over to here, I need to add 8m. So we get 10m minus 13 equals 27. And now it's a similar equation we just dealt with, so we'll add 13 to both sides. 10m equals 40, divided by 10, and m is 4. So for most of these problems, the key is just simply, again, you need to move the variable around so you can solve properly. Once you get down to this multi-step equation like here, the whole problem is pretty straightforward. But you have to remember adding the opposites to both sides so you can move it around. So something like this. So we're going to, and you don't have to always have the variable on the left-hand side of the equation. Most beginning students will move it there so they have a constant repetition. They always do it the same way. I like to move the variable around so the variable is positive. So I'm going to subtract 2y from both sides. And get 6 equals 2y minus 15. So I have to add 15 to both sides. 21 equals 2y. I divide both sides by 2. And y will be 21 halves. Or 11.5. I'm sorry, 10.5. So it doesn't really matter. You could have moved the 4y to the left-hand side and the 6 to the right and then divide there. You'd still get 21 halves for your answer. Again, I like writing them as positive variables. Now for this one, we have 12 minus 4/5 of times parentheses x plus 15 equals 4. Now one way to solve these problems where the fraction's outside the parentheses is to distribute it into the inside. I personally like doing that is if it'll go into it nicely. 4/5 won't go into x nicely, so what I'm going to do is I'm going to multiply everything by 5 to get rid of that fraction. So we'll have 60 minus 4 times x plus 15 equals 20. The inside part doesn't change because we multiplied the outside fraction by the 5. Now I'm going to distribute the negative 4 to both those. So 60 minus 4x minus 60 equals 20. Same side of the equation, so 60 minus 60 is 0, so just negative 4x equals 20. Divided by negative 4, and x is negative 5. Again, that's just my personal philosophy. I like getting rid of the fractions. You're more than welcome to distribute the 4/5 into the x and the 15 and then solve it that way. Nothing wrong with that. You'll get the same answer. This one now, we have multiple times we have to distribute. So we're going to distribute our 6 and the 3 to the problem. So we'll get 18a plus 6 minus 30 equals 6a minus 21. So to solve, we have to combine like terms first. So 18a minus 24 equals 6a minus 21. We then subtract 6a from both sides. I get 12a minus 24 equals negative 21. I add 24 to both sides. We get 12a to equal 3. Divide by 12. And a equals 1/4. Pretty straightforward. Again, the key is distributing properly, as we learned in the previous lesson, and then combining like terms properly. A common mistake would be to try and like add the opposite to get to combine the 30 with the 6. You only add the opposite when you move from left to right. Otherwise, you just apply normal PEMDAS. Okay, one more equation. So 5 plus 2 times n plus 1 equals 2n. So we distribute the 2 and get 5 plus 2n plus 2 equals 2n. We combine like terms to get 2n plus 7 equals 2n. And now we subtract 2n from both sides to combine them, and we get 7 equals 0. The n's canceled. And 7 does not equal 0, so it's a no solution case. And that will happen sometimes. If you get if your variables cancel and you get a false statement, the answer is no solution. Had the variables cancel and you got like a true statement like 5 equals 5, then that'd be an all real numbers case. So that is certainly possible to happen with the problem. Okay? So I want you to go ahead and pause the video so you can solve these 3 problems on your own. Use what we just talked about to combine like terms, distributing, and be careful with how you move things around. So go ahead and pause your video so you can work out that solution. Alright, so you should be getting 7 for the first one, negative 1/10 for the second one, and then all real numbers for the last one. The variables canceled, but you left with the true statement. That's why it's all real numbers. Alright, that's it for solving equations. We'll be back next time with some other Algebra 1 videos. Take care.